It all begins in the vast, silent theater of space. Imagine a time long before our world, before any world we know. Here, in the endless dark, a magnificent cloud of gas and dust hangs suspended. It is a nebula, a cosmic nursery of unimaginable size, swirling gently over millions of years. This colossal cloud is not empty. It is rich with the very elements that will one day form stars, planets, and even ourselves. Hydrogen, helium, tiny grains of stardust, the remnants of ancient, exploded stars, drift together in a slow cosmic dance. The forces of gravity, though weak, are persistent, patiently pulling scattered particles toward one another. Over an immense span of time, this gentle pulling becomes more insistent as material is drawn toward the center. A dense, spinning core begins to form. Pressure and temperature inside climb to staggering levels. The cloud, once cold and diffuse, is now a swirling disk with a fiercely hot heart. This is the birth of our star, the Sun. It ignites in a brilliant flash of nuclear fusion, sending light and warmth into space for the first time. Powerful solar winds sweep through the disk, blowing away the lighter gases and leaving behind heavier, dustier materials. The young sun sits at the heart of a flattened, rotating disk, rock, ice, and dust, all in the sun's gravitational embrace. Tiny particles begin to stick together. Electrostatic forces cause minuscule specks to clump, the very first step in building a planet. Within the swirling disk of debris, the process of planetary formation accelerates. Those initial clumps, held by static forces, continue to grow. Tiny specks become pebbles. Pebbles collide and merge to form rocks, a celestial snowball rolling through cosmic dust, growing with every rotation. These newly formed rocks, called planetesimals, range from boulders to objects hundreds of miles across. The early solar system is crowded and violent. Collisions are inevitable and constant. Often, if the impact is not too severe, bodies merge, creating larger objects. Relentless accumulation over millions of years. Larger planetesimals become dominant, sweeping up their smaller neighbors and clearing paths in their orbits. A few bodies outpace the rest. One is the proto-Earth. It grows rapidly, sweeping up vast quantities of rock and ice from its orbital path. Each collision adds mass and energy. The kinetic energy of fast-moving asteroids converts to heat, melting rock. With every major collision, the proto-Earth becomes hotter, a world forged in fire by relentless bombardment. As it grows, gravity strengthens. The larger it gets, the more it attracts. And the more it attracts, the larger it becomes. The era of countless small bodies gives way to a system dominated by a few large protoplanets. The proto-Earth carves out its orbit, no longer just rock, but a glowing sphere of accumulating matter. The relentless bombardment has had a profound effect. The proto-Earth is now so hot that its entire surface is a global ocean of molten rock. Impact heat, combined with radioactive decay in the deep interior, raises temperatures to thousands of degrees. Waves of molten silicate crash and massive plumes rise from the depths. Terrifying, yet magnificent. In this molten state, planetary differentiation begins. Materials separate by density. Heavy elements, primarily iron and nickel, sink toward the center, forming Earth's dense metallic core. That core will one day generate the magnetic field that protects the planet, an essential shield for life. Lighter silicates float upward, forming the vast magma ocean that will cool into mantle and crust. A layered structure emerges: solid inner core, liquid outer core, a thick mantle, and a thin crust. One cataclysmic impact with a Mars-sized object blasts debris into orbit. That debris later coalesces to form the Moon. Earth remains a sphere of liquid fire, radiating energy into space while internal heat keeps it molten for millions of years. This is the crucible in which our world was forged. Every feature we know, continents and oceans, has its origins in this inferno. As the molten Earth churns, it releases vast quantities of trapped gases. This process, known as outgassing, is the birth of our planet's first atmosphere. Volcanoes, great fissures, vents in the planet-wide magma ocean spew enormous clouds of gas into the sky. But this is not an atmosphere you would recognize. A thick, choking blanket. Water vapor, carbon dioxide, nitrogen, methane, ammonia, with virtually no free oxygen. The sky is dense, likely reddish-brown, surface pressure crushing, perhaps over 100 times today's. Carbon dioxide and water vapor trap heat, creating an extreme greenhouse effect that keeps the magma ocean from cooling quickly. The young Earth is trapped in a vicious cycle. Hot surface releases gases that trap heat, which keeps the surface hot. This is not a world of a few volcanoes. The entire surface is a volcanic vent. Fountains of lava, hundreds of miles high, erupt, while colossal ash and gas plumes blast into the toxic sky. The air reeks of sulfur and other noxious chemicals. Lightning crackles through ash-laden clouds. Perpetual thunder and fire, a truly primordial scene of raw geological power. Outgassing shapes the future. The atmosphere swells with water vapor, the planet's future oceans held aloft by heat. Though violent and hostile, this phase is transitional. Earth slowly releases heat and builds the atmosphere that will allow liquid water. For millions of years, Earth remains searingly hot, but slowly, things begin to change. The intensity of cosmic bombardment lessens. The planet sweeps its orbit clean. With fewer impacts, the surface cools toward a critical point. Saturated water vapor can now condense. High in the cooling atmosphere, the first clouds form, vast and dark, blanketing the planet. Then, the rain begins, a deluge of unimaginable proportions lasting centuries, perhaps millennia. Water heated to hundreds of degrees is kept liquid by immense atmospheric pressure as it falls. At first, it boils on contact, hissing back to the sky. A relentless cycle of falling, vaporizing, rising, cooling, and falling again. Slowly, the rain wins, the crust cools. Puddles form, then pools, then vast shallow lakes of boiling water. Bodies of water spread and connect. Rain washes the sky, stripping water vapor and some carbon dioxide. Carbon dioxide dissolves into the newly forming seas. Pressure drops as clouds thin. Eventually, the great rains fill the deep basins. A global ocean of hot, slightly acidic water covers most of the planet. This is the birth of the hydrosphere. Delivered from the interior as steam, returned as a great cleansing flood. The world of fire is quenched, giving way to a world of water. The great rains lash the young Earth. Steam and runoff cool the molten surface as vast first oceans begin to pool. Beneath the churning hot water, molten surface rock solidifies into a crust, dark, heavy basalt, like today's ocean floor. But this early crust is thin and fragile. It breaks apart and is recycled into the mantle. Vast plates drift on a hot mantle, colliding, pulling apart, and sinking, far more rapid and violent than today. Over hundreds of millions of years, partial melting and remelting concentrate lighter components. Lighter granite forms, less dense, reluctant to sink. It floats like scum on a pot of soup. Buoyant granite pieces collide and merge into larger masses, the seeds of continents. The first continental cratons rise, not sprawling continents yet, but small barren volcanic islands, battered by waves with constant volcanic activity, no soil, no plants, only bare rock. Yet their appearance is monumental. For the first time, deep oceans and stable, dry land. A new range of environments appears. Coastlines erode and lay down sediment. Rivers form, carving channels and carrying minerals and sediment to the ocean. Earth's surface becomes a mosaic of blue and dark rock, the sun a pale disk through a hazy, nitrogen-carbon dioxide sky. Continents grow, drift, collide into supercontinents, and break apart, a dance driven by heat for billions of years. Billions of years have passed since the Earth was a world of fire and rain. The slow, patient forces of geology and biology have transformed the planet. Continents have grown and shifted. Mountain ranges have risen and eroded. The oceans become home to a staggering diversity of life. The most profound change is in the atmosphere. Early life learned photosynthesis, harnessing sunlight and releasing oxygen. For hundreds of millions of years, oxygen rusted iron in the seas, settling as banded iron formations. Eventually, the oceans could hold no more. Oxygen poured into the air, building the ozone layer that shields the surface. With a protective atmosphere and stable continents, life colonized land, plants made soils and shaped climate. Animals followed, first invertebrates, then fish onto shore, then the great ages of reptiles and mammals. The Earth, once silent and sterile, becomes a tapestry of deserts, forests, grasslands, and ice. From space we see the culmination of this story. A brilliant blue jewel marbled with white, set against blackness. The blue is ocean water. The white, clouds in an oxygen-rich atmosphere. Green and brown, continents teeming with life. Born from a cosmic cloud, forged in fire, drenched by floods, and slowly sculpted into the vibrant, living world we call home.